This week's episodes were brought to you by the generous support of Andrew Henninger. Hey folks, Quilly here, and welcome to another Unity program tutorial. We are going to be working on our base building game some more. So we've got a lot of things in the queue. I actually considered adding in the system where we have sort of loose inventory items like building materials on the ground, so that when our character goes and creates the job, he can go and pick up the items first and then walk over to the job site and work on that. But it occurs to me, if we're going to start doing more work with the job system. Oh, in particular, another one of the things that is bothering people is the standing on the tile. That's actually really easy to adjust. We just stop the path finding to our destination tile one tile earlier, and then it would just work perfectly fine. There's that, but the other thing as well is right now our job queue is just that, a very simple job queue. We're just using the base queue data structure provided by the C# generics codes. For the job, which means our character always grabs the oldest thing on the queue. So if we do something like this with the wall building, after he builds this, you'd probably like it if you went and built this wall, but this one down here is the oldest one on the queue, so he's going to do that first. So we're going to, at some point, want to make a pass of the job queue system and prioritize jobs that are nearby, or ideally, perhaps, jobs in the same room. And only when this room is done, then maybe we'll check adjacent rooms to see if they have jobs in there. We might have some sort of other sort of super priority queue for kind of global jobs that I don't care about, you know, they will override. But some sort of priority system maybe, so that if there could be some sort of job that we would put over here that you would do before you do that. But that'll come a little bit later. But already, there's a great possibility that either in pathfinding or at least in our job picking system, there's probably room for optimization by checking our immediate surroundings. And rather than sort all the jobs in the entire world based on distance to this character, although we could just do a generic Dijkstra map that might supply that just fine for us in the future. But we could do this sort of room-based checking. And certainly we can build a pathfinding graph of rooms. But even if we ignore all that, we still need to know what is a room in our game, because this is a space-based game and we are going to care about sort of oxygen and things like that, right? If a room is not enclosed and it's open to space, then all the air will leak out on it and our people will die. We're going to imagine that we want some sort of mechanic for that. We might do temperature things, we might do all kinds of different things, but at the very least, that sort of like room leaking thing is a good mechanic. Also, if we start making like bedrooms or something like that for our characters, well, we're going to want to know what that character's bedroom is, so that, you know, we can decide if the character is, I don't know, happy with their bedroom or something of that nature. So how are we going to detect if this is a closed room? Like, what is the difference between this over here, which is clearly an enclosed room to you and I, versus this, which is clearly not an enclosed room? Clearly, this room is exposed to space over here. Well, the difference is obvious that there's no wall enclosing that. How are we going to be able to detect that in programming terms? Well, there's actually, I like everything else, there's a lot of different solutions, but I feel like the simplest and potentially the most effective way will simply be to use the flood fill algorithm. It's going to be really simple to implement. It should work relatively well, and I think it's going to work pretty darn fast and effectively as well. So how does the flood fill algorithm work? Well, if you, like me, are a little bit older and have a lot of experience on very slow old computers, you've probably used in sort of these paint programs, when you use the paint bucket tool to fill in a whole area, you may have been on a slow enough computer where you could actually see it sort of fill in pixel by pixel, or at the very least line by line. And these represent a couple of different ways to do these. Use a paint bucket tool to fill in an area on your drawing, right? Well, we're going to use the exact same algorithm to do that, where we're going to start in one of these tiles, say here, and then we're going to expand outwards. And what we're going to do is we're going to keep doing that until we either run out of tiles, right? So every time we hit a wall, we stop there. So either we will run out of tiles, or we will hit a tile that is empty, that is open to space. And then based on that, if we hit a tile that is open to space, then we know that this will not be an enclosed room, and it is part of the outside. But if we go through all of these tiles and we only hit walls and then we run out of tiles to explore, then we know that this is an enclosed room, and we can say, you know, this is room number 1, then we do it here, and this is room number 2 and 3, and sort of room 0 might be our generic outside room or something of that nature. When we could tell each tile what room it belongs in, or come up with some sort of structure with that. So that's what we're going to do. We're going to implement a flood fill algorithm to do that. There's a couple of different ways to do that. We are not going to use a stack because I mean, probably we won't smash the stack, but it seems like a bad idea in general. So we'll use sort of instead of being recursive, we'll use we'll just iterate through these tiles, and it should be relatively fine. It's worth noting, probably a sort of scanline system might be slightly faster, but for the sake of simplicity, we'll start with the regular flood fill one. It'll be easier to explain, and then later on, if we need to optimize things more, we can do that. So how do we start? Well, like, how do we initialize, or what command do we put in that causes the room scanning, the flood fill, to restart? Is it every time a tile changes? Do we scan everything? I don't know if we need to scan everything. We could probably be a little bit smarter than that. Like, every time we plop down a wall, I guess what we could do is initiate a flood fill to the north, east, south, and west of that wall. And that's going to be really important later on, because if we do something like this, so right now, this is all part of the same room. This is our room number 1, or whatever it is. But if we put a wall in between those, then we've actually just cut this into 2 separate rooms. So every time we plop down a wall, a door, maybe later on a window. So clearly there's some sort of furniture type that is a wall enclosing furniture type, right? As opposed to a sofa, which does not enclose a room. If we put a sofa in that little gap, that would not cut this room into 2 separate rooms, but the wall does. So every time we plop down something that can form part of a room enclosure, what we're going to do is initiate a scan check of all adjacent tiles, and then reset the room IDs at that point. And that's it. We might use a numeric system. I think we'll have a class, actually, for rooms, now that I think about it. I think that's most likely what we will want. The tiles themselves might point to the room class, but that the rooms will have to be in an array that is numbered, so that what we can do when we do our scan, or a flood fill, we can just use an integer array for that, and that'll map to the room IDs or something of that nature. Anyway, let's get started. Let's create, let's create some sort of script in, is it a model? Yeah, I guess it is. And again, I'm going to want, for now, and this will probably be mostly empty, we're going to have some sort of room class. And the room class could do things like keep track of, I don't know, how much oxygen is in it, right? That's the sort of thing it's going to be there for. Float oxygen pressure, something like that. Or what we could also do, maybe we'll name it something like Atmos O2, because we might later have a value that is Atmos N for nitrogen, and float Atmos CO2. Whoop, there we go. Oh, there we go, like that. Right? So something like that. Let's for the sake of argument for now, let's just make these public values. And obviously they'll all default to 0 because that happens anyway, but let's make it explicit so that we remember for our own purposes. Let's make it explicit that, right, these would all start as 0, and that's fine. Okay, so there's our room class for now. It's certainly going to do more stuff later on, but for now, this is sort of just a placeholder for our own sanity, right? And then it's probably easy to imagine that in our world object, over here, in addition to keeping track of tiles and characters and furniture, we probably will do something like a list of rooms. I think that's pretty fair. Here, let's do that because it's nice and cool, right? We've got a list of rooms here, and wherever we initialize our furniture array, this equals new list rooms, or list of room. There we go. Do we do that anywhere else? I mean, I should really have that in one central location. I think we do. I could also do a find to make sure that it's okay. If we just search for something like new list. What? That's impossible. Why is it only finding the one? Hello. New list. I clearly have more than one instance. Thank you very much. Okay, yeah, just this one place is where it all gets set up in the setup world. Excellent. So we set up an empty array of rooms in here, or an empty list of rooms. We'll mostly be using it as an array, but yeah, that's fine. All right, so we have something sort of like that. And I guess one of the things I will do is in our furniture class, and yeah, this is the other thing, these parameters and actions, and is enterable, all this, I'm very convinced we're going to be writing this in a much, much cleaner way later on. have no doubt about that. We'll just leave it in for now because it technically works. But this was very much done like on the cuff. So we'll come back to it. If it's bothering you, don't worry about it. We'll take another pass. Now, rather than the parameter, I think that for our furniture, very much like movement cost, which is in here somewhere, like movement cost, I think something like public bool, something like, what would we call it, like room enclosure, room blocker, room splitter, room enclosure is going to be a firm sort of trait of our tiles over here. And mostly, right now, it's going to coincide with things that have a movement cost of 0. But in theory, later on, we might have movement cost of 0 on some tiles or furniture. So things that block furniture but doesn't actually enclose a room. So I guess we'll do the same sort of... sort of makes it, well, it's sort of read-only, but it's not really read-only. Could any of these ever change in runtime? I don't know. For now, we'll just make it so it's still just set in the class. And then we will make sure to properly copy it. This is when we copy from our prototype into here, so we'll do that. And then also with our constructor over here, we'll make sure to go and grab room enclosure, can default to false. Da-da, da-da. Okay, so now our furniture supports this room enclosure flag. And I guess when we go, oh, it's in the world class. That's still currently where we set up all of our furniture prototype. Oh, there it is. Go to declaration. Right, so we're going to want to say that our walls enclose rooms, and so do our doors. They both count as part of that. All right, so I think we've got the data in there for that. So all we want now is whenever we create a new piece of furniture, right, and we've got something like that. We've actually got a callback here in world that already gets called. I guess it's not a callback now that I think about it. We have this place furniture function, which is the only place where furniture happens. And then it does call the furniture created callback. So either we could register our own callback here to also be called, or we could just add some extra code here. And I think it's probably fine for us to add the code here, since this is the place where furniture should get placed. So what we do is we place an instance here, so we find out what the object type is from a string. We find it in our furniture prototypes list. Then we place that prototype in the tile. That makes a copy of our prototype at that point. Returns furniture, which might be null if there's a problem with it. Most likely there's already a piece of furniture there. So it can return null and bail out. Assuming it hasn't, then we make sure to add that one piece of furniture to our overall list so that we can keep track of all the furniture. Currently this is used for serialization and deserialization. And also I think every frame, I think we also call any update functions on all this furniture. And then assuming it was created, we go and run this callback, and we invalidate the tile graph here, right? So this is the reset the pathfinding system, like that. I suppose we technically only have to run that if the furniture that we install has a movement cost other than 1. That's actually an interesting possible optimization. If fern.moveCost not equals 1. Since tiles return movement cost as their base cost multiplied by the furniture's base cost, or movement cost, a furniture movement cost of exactly 1 doesn't impact our pathfinding system, so we can occasionally avoid invalidating pathfinding. Pathfinding. Oh my God. Graphs. And later on, another possibility, right? To do. Can we, once rooms are implemented? Nah, I don't know. I was going to say, can we only invalidate the pathfinding within a particular room? But I think we can leave that off for now. So we'll do that. All right, so a little note. We can technically optimize a bit if we do have furniture later on that doesn't change movement costs. For example, if we end up getting like rugs or, I don't know, decorative items that don't slow down people can walk through a tile containing some sort of decorative item without impacting their movement, then we don't have to invalidate the whole graph. That's great. But somewhere in here, and presumably, well, it's going to have to be after this, we are going to have to go and do our flood fills to determine whether our rooms are enclosed or not. I'm trying to figure out if there's an optimization available. I mean, if the tile graph, you know, what if there's like, you know, invalidate room graph, right? At the same time, that's clearly the case. So we're probably going to want to graph rooms so we know which rooms are adjacent to one another. So it's going to have to be before some of this. I don't know. Let's assume it's here. Do we need to recalculate our rooms? Let's do it before we do. We call these callbacks and before we redo our pathfinding. I think that's probably a fair place to put it. So if the furniture dot what's it called? Room enclosure is true. So if this furniture is a room enclosure type, then yes, we have to recalculate it. And what we're going to do is call some sort of function to get that started, right? Some sort of do room flood fill scan something or other. Where are we going to do that? Well, I mean, it could be part of our world because it is something that happens sort of worldwide. It needs to be aware of all of the tiles, all of the furniture, etc., etc., etc. In fact, I think it has to be in a world now that I think about it. Well, not necessarily. What I was thinking is I could just make a static function in the room here just to segregate out the code, right? This is code related to calculating rooms, so why not have it in the room file? The one downside is it does have to access like all the things in world. If at some point furniture, for example, is not public, then we'll need an accessor function for that, which might slow things down. The tiles are not public, but that's actually okay, because even if I were doing the calculations within world, I would still be using the getTileAt function because it's a lot safer. It really doesn't add a whole hell of a lot of overhead at all, so I'm quite keen on using that. So okay, with that in mind, let's use for room. Yeah, but it's the world itself that has the array of all the rooms. Poop. I mean, I guess in the end, it doesn't really matter where you do it. You can get the data in one form or the other. I'm trying to figure out which place would result in us having to put in the least amount of work to access things, and also which place encapsulates data the best, but also which place keeps our data as clean as possible. You know what? F it. We're going to do it in the rooms code over here. So I'm going to have some sort of public or static function. I guess we do public static void do room flood fill. Sure. Okay. And starting tile. Something like that. So in here in the world, oh, furniture strike controller. No, I don't want that. World. There we go. In the world, when we place furniture, so if the furniture is a room enclosure type, then we call room.do room flood fill for furniture.tile. I guess we could pass it the piece of furniture. Either way, it doesn't really make much of a difference. You know what? I suppose logically then, you know what? I actually will ask for a piece of furniture. Source furniture. Or some damn thing like that. We're not going to be typing this name a lot. But, oops, source furniture is the piece of furniture that may be splitting to existing rooms, or may be the final enclosing piece to form a new room. There we go. So we're explicitly getting the piece of furniture that this piece of furniture itself won't exist in a room. This is going to be between two rooms. Well, assuming it creates two rooms, right? Because the question is, like, if we sent a tile, is the tile we're sending supposed to be an empty one? So clearly, whatever tile this is on is not the empty tile. So what we're going to do is check the northeast, southwest neighbors of the furniture's tile, or and do flood fills from them. The point is, we're not going to start the flood fill on the tile that the furniture is on, since that can't go anywhere. There's an enclosing piece of furniture on that. We're going to start the flood fill from the tiles adjacent to this one. So we're going to end up doing 4 different flood fills at that point. Well, not necessarily. Only, like, because it's entirely possible, right? If we go play, we have a compiler error. Oh, just pass the furniture, please. Okay, good. Hit play. Load. I mean, it's entirely possible, if we plop down a wall here, that one flood fill will fill this all in, and we won't need to do the flood fill from the other 3 because that will already be touching, right? So we have to check to see if we have to do multiple ones. And of course, if there's walls already above and below, we don't have to do flood fill. We check that tile, it's already full, we go on from there. But I think that's the sort of logic going on here. And so our room, our do room flood fill here will what? I mean, we have a rooms list. Do we just start off by destroying the room? Like, something like, if this piece of furniture was added to an existing room, which should always be true, assuming we consider outside to be a big room. And I think that's fair, right? Let's assume there's always one room, which is just the outside. So room with index of 0 in our list over here is the outside room. To the point where maybe when we go and initialize our rooms array or rooms list over here, like, should we just say something like rooms.add new room, create the outside? I guess so. I don't know, I think that makes sense. Because then again, what I'm imagining is that going forward in the future, each room will keep its list of inventory rather than having one giant list like we have here of, when we have our loose inventory items sitting around. Instead, each room will have its own, and then that'll help with our characters trying to find the correct type of object. And that's the thing. For jobs, I think a Dijkstra map for jobs might be a really good way to optimize helping our characters find their closest job. Although we'll probably need multiple Dijkstra maps for all the various job types, right? Like if our character is going to first prioritize jobs like putting out fires, then we need a map for that. And then we need another map for repairing tiles, and another map for constructing things, and another map for doing certain types of jobs, etc., etc. So we might end up with a lot of those. We could also end up with Dijkstra maps for every type of inventory object in the game, so that when you are looking for one, you can just refer to that map and you'll automatically know where the closest one is. But at a certain point, you start to wonder if having dozens of different maps, each one of which will get updated relatively frequently, is better than not having maps for all the types, and just on the situations where a character is looking for a potato, then we just do a pathfinding check there. Especially if we have room-based inventory, because then those checks at that time might be extraordinarily fast. Computers these days do have a lot of RAM, so keeping the extra maps in memory isn't too bad. Although if we do tend to trigger a lot of garbage collection because we've written it inefficiently, that might still come back to bite us in the ass. And recalculating all those maps is not going to be a free job. So it will take a little bit of time to calculate a full map, whereas finding a nearby object could actually be quite quick. So I don't know. We'll play that one by ear. Maybe we'll do some testing. That might be the pathfinding system. If there's anything in our game that is going to be well suited to multi-threading, doing the pathfinding system, in particular generating new Dijkstra maps, is definitely going to be the place to do that. So we'll revisit that later on. But okay, so we're going to assume there's an empty room. And then what else? I guess over here, we're going to do something like delete that room and assign all tiles within it to be outside for now, right? Like, so the idea is, I should just keep this running. Although I guess when it recompiles, it might go crazy. All right, if I tell it to build a wall, so let's say this is room number 1. So you build the wall, it goes down. First, it goes and takes all the tiles assigned to room 1, puts them back outside, and then starts the flood fill. Now, building a wall tile will never actually cause things to become outside. But it's in this situation here, you can easily imagine that what we want to do is when we do this, delete room number 1, and then do flood fills on either side of this, and we end up with a new room number 1, or most likely, like, I don't think the room indexes are going to be hard-coded in here. So mostly it's delete this room, do the flood fill, we discover we have created an enclosed room here, assign all the tiles there, do another flood fill over here, we could discover we have another closed room there, assign all the tiles to a new room at that point, and then, good, so we have 2 new rooms. The alternative is we could do some sort of thing where we don't delete the existing room, we do the flood fill, we find out, enclosure, and then we just, at that point, unassign only half the tiles from the existing room. I feel like that would be a little bit messy, and I think that the overhead of just deleting a room and then creating a new room, I think is very, very, very minimal. So I think it's going to be fine. I guess the only gotcha is deleting a room, quote unquote. I mean, again, we're not, we're in a managed memory environment, and even if we weren't, we'd have to make sure to reset our pointers. Deleting a room in this case mostly just means unassigning all the tiles. So the only things that should point to a room in memory should be the tiles will point to a room they belong to, and also we're going to have that one list of all rooms in our world. So as long as we set all these tiles to be null, which I guess the null room is probably the outside room, now that I think about it. We might still want to have an explicit outside room. But yeah, so we just unassign all the tiles, we point them to either to null or we point them to the outside room, and then we make sure to take the existing room out of the list from our world, and that'll be it. It'll be garbage collected. And the individual room memory objects are microscopically small. I guess the pathfinding system, yeah, we'll have to be a bit on our toes, but I think the cleanest and simplest way to do it, at least for now, we can always come back and re-optimize later on, is just to say, let's just, whenever we place a piece of furniture down that is a room enclosure type furniture, we will delete that room effectively and then create a new room. And sometimes, in some cases, again, when we do something like this, build wall, I'll delete this room and then mostly just recreate it afterwards. And if that turns out to be slow, if we turn out to have little tricks, and there are plenty of tricks that we can use to fix this. For example, if we put down this piece of furniture here and we check all our adjacent tiles and they all belong to the same room, right? If we check our north, south, east, west tiles, and they were all part of room, number 1. They're all part of the same room. Is there any way that this can split that room? No. There's no way that that can split that room. In fact, even if we do here, I guess if a new wall has 2 corners, no, that's not true. Because this could cause a split. Because I was going to say, let's say we have something like this, and our diagonal is going to cut rooms. Well, we have decided that you can't walk through diagonals. So the question is, if I were to do that, does that count as a room divider? Right? So if we have this, and we have that, and then let's move my character around again. Are these 2 separate rooms? Well, we'll have to make a decision about that. You can easily say either way, right? We can say, no, air can leak between these 2, or since you can't walk from one side to the other, no, they're divided. I think it's probably fine for us to say that these are 2 divided rooms. So then that doesn't work anymore, because what I was going to say is, imagine this tile is the last one we put in. Or here, let's go and redo this. I was hoping we'd find an optimization, but apparently I did not. So let's say we do this and we do this. Or that's not even the version, but let's try it one more time. So I do this. Oh. I do this, and then I do this. Right now, these all still belong to the same room. When I put this one down, right over here, again, it would check north, south, east, west. They would all be part of the same room, but this is still something that ends up cutting these two rooms in half. So we can't avoid that check. So again, and this is actually just a way to ensure, we might be able to find optimizations later on, but this will ensure that if we just delete this room and then recreate them afterwards, we avoid making an optimization attempt that actually screws up our system. Premature optimization is often bad. Most likely this will actually not be a very time-consuming job at all, because it'll bail as soon as it runs out of tiles. So unless you're building huge enclosed rooms, right, that check might take a little while. But most of the rooms are going to be smaller, and if it ever hits an outside tile, then it bails instantly. So I think it's going to be okay. All right, so what we don't have yet is in our tile over here. Like we don't have a room. So let's have something like that. For now, let's just make it public. Okay? We might turn it into an accessor, a getter, setter sort of thing, or something of that nature later on. We'll see. But for now, we can do something like just make a public room over here. And when a tile gets created, and we do set tiles. Well, I mean, I guess we don't create tiles per se. Where do we create tiles? We create them here. I guess what we want to do is tell all these tiles they belong to room number 1, right? The outside room. So let's change this around, I guess, so that we create this here. And so when we create this tile, we'll also say, hey, tile.room is rooms 0. Rooms 0 is always going to be outside, and that is our default room. I mean, we could explicitly have a variable called, outside room or something of that nature, but I think this is going to serve us perfectly well. So what we're going to do, do we want our rooms to know what tiles are in them? Probably. So something like, okay, we can have a list of tiles. Let's make a constructor, public room, and all it does is set tiles. No, what? Why would you do that? Tiles equals new list, like that. And maybe what we have is a public function called assign tile, to room, but it's room.assign tile, so it takes in a tile like that. And what it does is it sets tile.room to be equal to this, and if tiles dot contains t. So if the tile already has, if our tiles array already has this tile in it, then we can just return right away. But otherwise, we set t.room to this, and we set tiles.add t. There we go. So rooms now know what tiles are in them. And what if we do something like public void unassign all tiles? Actually, do we need to do that? We really don't need to clear our list. That's not really the concern, although I guess we will at the same time. It's mostly that we want to go through each tile in our array and tell them that they're no longer assigned to us. But we don't just set them to null. Instead, we want to set them to the outside. We never want a tiles.room to be equal to null, ever. So I guess what we're going to want to do is something like this. For I is less than tiles.count, and something like, oh, hit enter. Tiles I.room is equal to tiles i.world.rooms0. Assign to outside. I don't like doing this. So what I'm going to do is we don't need a variable to hold a pointer to the outside room, but I will go, I'll put it right here for now, get outside room, and all it's going to do is return room 0. Like that. And then we can go and we've got a nice central location to clean this up later on if it's a problem. Get outside room, and then over here, world.get outside room. There we go. And then we can just recreate our array over here. So now we have no more tiles. All the tiles that used to be in our room now point to outside, and our own list of tiles that we contain have been reset to a brand new list. The old list will get garbage collected, and that will be fine and peachy. Okay, so when we put down a new piece of furniture, or in rooms, do room fill, the first thing we do is, right, so this is a static. So this is a static that belongs inside of a room, but at this point we don't have this room. We don't have a room. But our this room in this case would be something like sourceFurniture.tile .room .unassign all tiles. So basically we eliminate that tile from the list. Well, that's not true. First we unassign all the tiles, but then it still exists in the list in the world. So rather than call this directly, I think world should have something like public void eliminate room, delete room, room r, so r dot unassign all tiles, and then rooms dot remove r. Oh, but what if it's outside? We can't delete the outside room. That would be bad. If r is equal to get outside room, then debug.log error tried to delete the outside room. Return. There we go. So instead what we do is we go if, so we got to check, make sure it's not outside. If sourceFurniture.tile.room not equals sourceFurniture.tile.world. Actually, well, let's keep a reference to the world. It'll make it a lot more convenient. World equals sourceFurniture.tile.world. There we go. That'll shorten some of our writing later on. If it's not the outside room, then we can safely delete it. Now, technically, we were doing that check somewhere else as well, but let's make it explicit here. So it's not, so then we can say world.delete room, like that. This reassigns tiles to the outside room. There we go. And it removes the room from the old list. Good, okay. So, of course, right now, nothing belongs to room. Everything belongs outside. So, right now, whenever we plop down a piece of furniture, because this is still executing, right? We're doing this already. In, how come I lost my my outliner? Come back up here. In place furniture. All right, we're doing that. If it's type of furniture that is a room enclosing furniture, like a wall or a door, we call do room flood fill, which is over here, which is going to attempt to delete rooms, although right now everything is in the outside, so this shouldn't do anything. Cannot, oh, I pressed, I was going to say, I have an equal sign instead of a double equal over there. I love the fact that that's an error. hate languages where that's something you're allowed to do. So if I load, it ran all those functions, but it's not doing anything. If I hit build wall, it is attempting. It's saying, hey, we're going to delete this room, except unless it's the outside room. It's first checking to see it's an outside room. It's not, so it bails early. Okay, good. Well, we've done a lot of structure here. The next thing we're going to do, and we're going to have to put a cut in here because this video is going on too long as is in our room code, we're going to do the actual flood fill at that point, which is going to create all of our rooms. And what we're also going to do is we're going to add, and actually we could do that now already with the outsideness. When we're playing here, load. What we're going to do is I'm going to put in tooltips. So when you're mousing over things, it'll tell you some information about the tile. It'll tell you, what the tile type is, what the furniture in the tile is, and also what room it belongs to. But that we'll have to wait until next time. And at that point, we'll be able to see that we have individualized rooms, and hopefully that will work okay. All right, thank you very much for watching another episode, folks. I'll see you next time. Thank you to everyone who pledged to support this in February and is making these videos happen through March and early April. And of course, these mic check supporters. We've got Wes Eldenboving again, Craig Mortel, Nail Vikstrom, Neil Blakely Milner, Speedy Savant, Valent Cake Fiend, Aaron Toyson, Marius Field Vold, Ole Peter, Talgo, probably Ole, Julian Ogier, Lafone, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and Andrew Henninger. And everyone who just watches and shares and favorites and comments and subscribes, thank you so much for just continuing to make these videos a thing that we can do. I think it's pretty awesome, and I hope you do too. See you next time, folks.